Okay, so when I do A versus C, these 27 people would choose who? A, because they have A ranked higher than C. So we put 27 under A. The next 19 people, who would they choose? A also. These 8 people would choose C. These 15 would choose C, and 2 would choose A. So A is going to be the winner. Add those up, and it'll be the most. Okay, so A has now won 2 of its matchups, so it's possible that A is Condorcet. If A wins this last matchup, then A is Condorcet. A can beat everybody head-to-head. So A versus D. These 27 people would choose D because it's ranked higher. The next 19 would choose A. The next 8 would choose D. And then these 15 would choose A. And the last 2 would choose A. So 27 and 8, that's 35. And 15 and 19 is 34, 36. So A wins this head-to-head matchup. A wins all of its head-to-head matchups. That makes it Condorcet. Yeah. Mm-hmm. Yeah, and check that one. That's a good way. Yep. Yep. And if you hadn't come across that, you could have just checked all of them. Do all of A's matchups, all of B's matchups, all of C's matchups, all of D's matchups. So it'd take a long time, but you could just do them all and see if anybody's undefeated. Okay, anything else from the homework? Yeah. Okay. Part B. Okay, so yeah. No. Yeah. Okay. So there are 441 voters, and there are 4 candidates. So if you split the votes equally, right, as equally as possible, pull up a calculator. If you do 441 divided by 4, that would be 110.25 votes per person. You can't really split a quarter of a vote, but 111 votes for one person. Everyone else could have 110. So you need 111 votes to get a plurality. Okay, so hold on. Let me pull B up here. So I'll put in 111. Okay. And then B, suppose that at least 45 votes are needed to have a plurality. What is the number of candidates in the election?
I didn't think I was supposed to.
Oh, you didn't realize we were.
Yeah, I didn't think. I said, if we can't.
Oh, I see. Yeah. Yes, it is. So, yeah. So the thing, if part of the question is written in like the main thing, and then there's A and B, you can assume this stuff in the main part for both questions. Yeah. Yeah. Okay. So we are assuming 441 voters still. So we've got 441 voters. And it takes 45 votes to have a plurality. So this time I'm going to divide 441 by 45. And I get 9.8. So that would be, so how many candidates do you think there are? 10. Okay, so if we round that to 10, let's just check. If I have 441 and I divide by 10, That's 44.1. So that means that we could give 45 to one candidate, 44 to the other 9, and that would add up to 441 votes. So it's got to be 10 candidates. No, I divided for both of them. This one I did 441 divided by 4 candidates, and I get 110.25. Yeah, so this is if everybody gets equal votes, right? An equal number of votes. So in order for somebody to win, they would have to have more than that, so you round up to 111. And then in this one, I did 441 divided by 45 votes, and you get 9.8 candidates. And then we said, well, you can't have 9.8 candidates. We'll round that to 10 candidates. Yes. No, Wednesday. Wednesday of next week. Yeah. This homework and whatever is assigned for today's class is due Wednesday of next week.
And that's all, like what homework is assigned is all in that my math lab there.
Yes. So let's see if we go to the general homework page. So these are the assignments, and they've got due dates on the left here, and these, like, this is the homework that goes with class 1, right? And this is the homework that goes with today. All 3 of these things are going to be due Wednesday next week. This is like just a little orientation to this program. Yeah, just to get you comfortable with how to enter answers and stuff, and all the features. Good, good. All right, anything else? Remaining questions? All right, let's start our lesson then. So you have a packet, the packet that I gave you in class 1. That's right, yeah. Anybody else who wasn't here on the first day? Okay. All right, so we're at class 2. We're going to talk about sections 3 and 4 in chapter 1. So last class, we studied preference voting, and we studied one method of determining the winner of an outcome, the plurality method, the person who has the most first place votes. It always satisfies the majority criterion, which means that if somebody gets a majority, they will definitely win. But we saw that it can sometimes fail to satisfy the Condorcet criterion. That is, someone can be undefeated in their head-to-head matchups and lose, right? And we saw that the results are easily manipulated by insincere voting. So now, today we're going to study 2 new methods for determining the winner of an election. This first one is called the Borda count method, and somebody, might have been you, last class suggested points. Maybe it wasn't in here, I don't remember. So the Borda count method is where we assign points to each place on the ballot. So if somebody votes for you in first place, you get n points. Okay, if there are n candidates, you get n points. If somebody puts you in second place, you get 1 less point than that, n minus 1. All the way down until last place, which only gets 1 point. So here's the preference schedule for the results of a math club election for president. And the candidates are Alicia, Boris, Carmen, and Dave, A, B, C, and D. So we're going to use the Borda count method to determine the winner. Because there are 4 candidates, first place is going to get 4 points, and second place will get 3 points, and third place will get 2, last place will get 1. So last place always gets 1 point. And then as you go up, you just keep adding a point. 2 points, 3 points, 4 points.
points associated with choices.
With the place.
Places.
Yes. Yeah. Yep. So these 14 people who put A in first place, that means that A gets 4 points for each person who did that. So each time someone puts A in first place, A gets 4 points. So from this stack of ballots, 14 ballots, how many points should go to A?
Or, no, sorry.
This. So you get 4 points every time a single person puts you in first place.
You just multiply.
Yes, you're just multiplying 14 times 4. Every person that puts you in first place is giving you 4 points. So you get 4 points times 14 people who put you in first place, which is 56 points. So we'll put a little 56 right there. So then we can work our way across, and we're going to give 4 points to each candidate who is in first place. So C got 10 people to put them in first place here. So we do 4 times 10, and we get 40 points. Goes to C for that column. And for this column, 8 people put D in first place. So we're going to do 4 points per person. So that's 32 points total for D. And here, 4 people put B in first place. So we have 4 times 4, which is 16. And 1 person put C in first place in this column. So C gets 4 points. So then we go through and do it for the next row for all the second places. But this time we only give 3 points for each person. Okay. So we do 3 times 14, which is 42. And then 10 times 3 is 30. And 8 times 3 is 24. And 4 times 3 is 12. And 1 times 3 is 3. Then we go through and give out points for all the third place selections. 2 points per person, 2 points per ballot. So C had 14 people put them in third place, so they get 28 votes. 14 times 2. And then 2 points times 10 people is 20 points for D. 2 points times 8 people is 16. 2 points times 4 people is 8 points. And 2 points times 1 person, 2 points. And then in the last column, you get 1 point for a last place vote. So you get 14, 10, 8, 4, 1. And then you got to add each candidate's point total. So candidate A has a 56. So you got to find all the A's in here. A 10, an 8, a 4, and a 1. So we have 56, 66, 74, 78, 79. And then candidate B has 42 plus 30 plus 16 plus 16 plus 2 is 106. Candidate C, 28 plus 40 plus 24 plus 12 plus 4. Yep. Thank you. Sorry. 28, 40, 24, 8, 4. Good. So that's 68, 78, 82, 90, 94. And then candidate D, we have 14, 20, 32, 12, and 3. So that's 34, 66, 76, 78, 81. So who wins using Borda count? B with 106 points. What do you think? Yes, I'm going to have you do it on your own in just a second. So this is the same. This is just the same election. Who would win this election if we determined the winner using plurality? A. Most first place votes would go to A with 14. So we have different winners using different methods. Here, using Borda count, B wins. Using plurality, A wins. Which method do you think is better in this case? Maybe we should look at the preference schedule. Who do you think should be the winner in terms of fairness, A or B? Borda count, how come?
Is it? It counts every section because B is in Condorcet.
B is a Condorcet candidate. Okay, so B is Condorcet. That's good. And what is it about?
More people prefer A.
Yeah, so B wins all of its head-to-head matchups. So everybody is comfortable with B. Yeah, even though the most people put A in first place, everybody is comfortable with B. So B is a good like compromise candidate because A is a very polarizing candidate. We have a lot of people who have them in first, and everybody else has candidate A in last. So B is a good compromise candidate. So Borda produces a good compromise candidate, someone that everyone can live with. That's sort of a generally true property of Borda count. It's good at producing the compromise candidate. So, what do you like about Borda? Still easy. Yep. Yep, we still like it because it's easy, just like plurality. People can understand it. It's really important.
Very
Clear.
clear.
Yes, all of their opinions count. It takes into account all the information on the preference ballot. Right. So plurality voting only looks at who you voted for in first place, and then it just throws away all that other good information, like the information of who you really don't want to win. So Borda actually takes that into account. A lot of nice advantages to the Borda count method. So before we try to list disadvantages, we're going to look at another example. So we have 4 finalists for the job of school principal, A, B, C, and D. And this is the preference schedule. I want you to, so first we need to decide if there's a majority candidate and a Condorcet candidate. So how many people voted in this election? 11. So what would a majority be? 6. Did anybody get 6 first place votes? Yes, candidate A, right? So candidate A is a majority candidate. Six out of 11 votes is more than half, right? So if candidate A is the majority candidate, let's see if they're a Condorcet candidate. If I do A versus B, A versus C, and A versus D, we want to see if A wins all its matchups. So look at that first column. If you had to choose between A and B, these 6 people would choose A. Yes, why? Can you explain? Yes. A is going to have 6 votes every single time, no matter who we match it up against. These people are going to pick A, right? And there's only 5 votes left. So no one else can beat A in a head-to-head matchup. So A is always going to win. So a majority candidate, this is a good conclusion, a majority candidate is automatically a Condorcet candidate. So you can be Condorcet without being majority, but you can't be majority without being Condorcet. Okay, so I'm going to write it down. So a majority candidate this is a conclusion we're drawing. We already answered that question, right? Yes, A is a majority candidate and a Condorcet candidate. I should write that. So candidate A is also a Condorcet candidate. So we see candidate A is a majority candidate. They got 6 of the 11 votes. Candidate A is undefeated in head-to-head matchups, which makes them a Condorcet candidate. And it turns out that you can't be a majority candidate without being Condorcet. If you're the majority candidate, you are automatically a Condorcet candidate. No one can beat you in a head-to-head matchup if you have a majority of the votes. However, you can be Condorcet without having a majority. Does that make sense? If you have a majority, you're automatically Condorcet. But if you're Condorcet, you don't automatically have a majority. So, according to our 2 fairness criterion, the most basic ones we have, who should be the winner of this election? A. We think that any fair method should produce A as the winner, right? Because A is a majority candidate. They win all their head-to-head matchups. So let's go ahead and figure out who wins using Borda count. So I'm going to have you do this in your groups. Okay, so who wins using Borda? B. It's B, yeah. So if you didn't come up with B with how many? 32 points, right?
Yes.
Borda, B wins with 32 points. So if you didn't come up with that, you might want to go back and try it again. Who wins with plurality? A. With 6 votes. 6 first place votes. Okay. So now, what are some disadvantages of the Borda count method?
You can elect someone that is not where you are.
Yeah, you can elect you can have a majority candidate or a Condorcet candidate lose. The plurality is the one who gets the most first place votes. They don't need a majority. Yeah. So some disadvantages are that Borda can sometimes violate the majority criterion and the Condorcet criterion. That is, it is possible to have someone get a majority of the votes and lose. And it's possible to have someone win all their head-to-head matchups and lose. So this is a big drawback. Because Borda is like that person who tries to make everybody happy and ends up making nobody happy, right? Sometimes. So Borda is trying to come up with a compromise candidate because they see that a lot of people don't like A, even though a majority of the people do, they're trying to come up with someone who everyone can live with. Sometimes that's not the best thing to do. So the plurality method is used most often, but Borda is also a very popular method for running an election. It's used really often for like awards that are voted on, like the Heisman Trophy. You know that lots of people vote on Heisman Trophy candidates and they rank them and points are assigned. Music industry awards and acting awards. Are often used board account. Other sports awards like Rookie of the Year in, I think, basketball and things like that, they often use board account. Okay, one more method we're going to learn today is called plurality with elimination. It's also known as instant runoff voting, and it's also known as the Hare method. Hare is a name of a person. Yeah. So in this method, the thing that we don't like about plurality is that you can win with a very small percentage of the vote, right? That's one of the drawbacks of the plurality method. You could win with only, say, 10% of the vote. 90% of people voted for someone other than you. So what we do is we say, okay, we're going to tweak the plurality method so that someone has to get a majority of the votes. So here's how we do it. Count up the first place votes for each candidate. If a candidate has a majority, they're automatically declared the winner. Otherwise, you eliminate the candidate with the fewest first place votes. Whoever has the fewest first place votes is just gone. And then in step 2, you cross out the name of that eliminated candidate from the preference schedule, take them out of the preference schedule, recount the first place votes, and if a candidate has a majority, then they're the winner and we're done. Otherwise, eliminate the candidate with the fewest first place votes. And you continue to do that until someone gets a majority.
So you're getting rid of the first place, like second place.
Yes, will become first. Yep, everybody else moves up when you eliminate someone. Yes, exactly. Until there's a consensus, until we have a majority for one candidate. All right, we're going to do an example right now. So we're going to use plurality with elimination for this math club election. Same preference schedule we were using earlier. So round 1, you tally the first place votes. Okay, so A has 14, B has 4, C has 11, and D has 8 votes. So first we want to count up how many people voted in this election altogether. 37. So how many would be a majority? 19. So you do 37 divided by 2, 18 and a half, so 19 would give a majority. So I'm just going to write myself a little note here. Need 19 for a majority. Does anybody currently have a majority? No. Okay. So then I move to step 2, which is eliminate the candidate with the fewest first place votes. So who would that be? B. So B is going to be eliminated.
Still in the compartment of round 1, right?
Yep, we are in round 1. Once we eliminate B, we move on to round 2. Okay. Yeah, so these 4 people who had B in first place, now that B is gone, their votes revert to candidate D. Okay, so
So it goes on with the defaults automatic to the lowest one. After the-
No. I found that out by looking at the preference schedule. I said these 4 people had B in first place. If B's not there, we know that D is their second choice. So we give them to D because they have D in second place. So we get rid of it. Do you understand? We get rid of B, right? Because they have the fewest first place votes. So I added up the first place votes. So A got 14. B has 4 first place votes. C has these 10 plus 1, so C has 11. And D has 8 first place votes. Okay. Nobody has a majority, so we eliminate B. It's the smallest number of first place votes. B is gone. So B is no longer in the running because we say, okay, B has the least chance of winning. The fewest people like B will get rid of B. So then we go to the 4 people, just the 4 people who decided they wanted to vote for B. We say, okay, you 4 people, we're really sorry. B is gone. Who do you want to vote for now? Right? We don't have to actually ask them because we can tell from their ballot who they would vote for. They would say, all right, well, if I can't vote for B, I'll vote for D because they're in second place. Okay, so I'm going to add 4 votes. The 4 votes that I took from B now is going to get added to D. So in round 2, A still has 14 votes. B is gone. C has 11. And D has 12.
No, because then someone has a majority.
Nope, you don't stop until someone has a majority.
So you cross off.
Nope. Majority is 19.
Cross off C, we give the 10 points to D, and then D wins the point too, right?
Okay, hold on. Don't get ahead of me.
These can be the majority.
Okay, wait. So does anybody have a majority now?
No.
No. Okay, so who do I eliminate? C. So I have to eliminate C, and I have to decide who gets those 11 votes that used to go to C. We have to consult those voters. The people who were going to vote for C, we have to consult them and find out who they want to vote for now. So we say, well, these 10 people who voted for C have B in second place, right? But B is gone. B is gone, so we have to give their votes to D. So those 10 are going to go to D, and this 1 who had C in first place has D in second. So actually all 11 are going to go to D.
So now we're in the 3rd round.
Now, yep. Third round is recount the first place votes. A still has 14. C is gone. D has its original 12 plus the 11 that C used to have. So that's 23. So D wins. They've gone over 19 votes. D is the winner.
So that's majority criteria, right?
Yes. Yes, so there's no way we can violate the majority criterion here. If someone has, because round 1 is if someone has a majority, declare them the winner, right? So there's no way someone could have a majority and lose. So the same math club election has now had 3 winners, right? We had A1 using plurality, B1 using Borda count, and now we have this new method, plurality with elimination, and D1. Okay, so plurality A1. When we came up with the winner of this election using Borda, B1. Plurality with elimination, D1. 3 methods, 3 winners. No violation of the majority criterion. Yeah.
But you can still violate underside.
Condorcet? I don't know. I mean, we'll find out. We will. All right, so I want you guys to practice the plurality with elimination method. I gave you an election, 5 candidates, determine the winner. The winner of this one turned out to be who? E. with 153 votes. Okay, so if you didn't come up with that, you want to go back and watch the video of me explaining it again and try it again. Okay? Or ask someone at your table or come to my office hours or something. All right, so this next one, this was that controversial principal election that we talked about it earlier, and board account declared B the winner. So who would win if we did plurality with elimination? A, and it's super easy. We don't have to do any eliminating, right? Because we count up, we say there are 11 voters, which means 6 is a majority. So now we count up the first place votes. A has 6, B has 2, C has 3. The first step in plurality with elimination is, does anyone have a majority? Yes, we automatically declare them the winner. So sometimes plurality with elimination is very easy. Don't know. All right, so what do you like about it, plurality with elimination? Easy if someone has a majority. And Robert, what you said earlier, you cannot violate the majority criterion. That's a good advantage. Always satisfies the majority criterion. That's a big plus. It's impossible to lose if you have a majority. Anything else you like about it? It's kind of fun. Okay. I feel like it kind of builds consensus, right? You can't win with a very small percentage. Oh, you can't win with a very small percentage, right? So one of the disadvantages of plurality was that you could win with a very small percentage of the vote, and this sort of eliminates that. I mean, it kind of requires a majority eventually. So again, before we list its disadvantages, we're going to consider one more example. We have 3 cities, Athens, Barcelona, and Calgary, competing for the Summer Olympic Games. The final choice is made by a vote of the International Olympic Committee. The winner is chosen using plurality with elimination. For real, this is how the International Olympic Committee decides. So 2 days before the real election is to be held, they have a straw poll. Just a quick tally to see where people stand, right? So these are the results of the straw poll. Based on these results, I want you to figure out who's going to win who wins. So calculate the winner using plurality with elimination in your groups. Okay, fantastic. So it appears that C is winning with 18 votes in the end. Okay, C with 18 votes because it took 15 to get a majority. We just had to eliminate B. Their votes went to C, and we got the winner. So we're expecting Calgary to win. Everybody's thinking 3 days before the real election, everybody's like, ah, it's Calgary. Calgary's totally going to win. Not even close. So the results of the straw poll are supposed to be a secret, but the results leak out. Everybody loves a winner. So the 4 delegates in the 4th column decide to put Calgary first and Athens second. They're going to change their vote here, so it's going to go C, A. They changed their mind. After the straw poll, for the real vote, they said Calgary's going to win. Let's just vote for Calgary. We'll be on the winning team, you know. So they switch their vote. Instead of ACB, they do CAB. Switch their vote. So now here's the new preference schedule where we just replaced A with C and C with A in this last column. Determine the winner again using plurality with elimination.
Now, the second part of the question.
Yes. When I said create a new preference schedule, that's just talking about this switch. So we just did that. Okay, now just determine the winner. All right, so remember it was going to take 15 for a majority. So when I do the first place tallies now, A has 7, B has 8, and C has 14, right? So Calgary's in the lead right now, but who has the fewest first place votes? A, so we're going to eliminate A. And who are their votes going to go to? B. They have B ranked in second place. So I'm going to add 7 votes here to B. And in round 2, B is going to have 15. C has 14. B is the winner with a majority of the votes. So Barcelona now wins. This is weird, right? Because it seems like Calgary was the winner. The only change we made to the preference schedule was to help C, right? We just did something positive for Calgary. Yet it caused Calgary to lose the election. This is a victim of a quirk in the plurality with elimination method. It's just a weird thing that happens sometimes. And it's actually an example of a violation of a new fairness criterion. It's called the monotonicity.
So this straw violates this.
Yes. Yeah. Monotonicity criterion. Think of monotonicity as in monotone, as in like the same, right? The same thing should happen. You should have the same winner. If only positive changes are made to the ballots, the winner should be the same. So that's what this criterion says. If candidate X is the winner and we do the election again and we make only positive changes for candidate X, then X should remain the winner. So in our last example, this didn't happen. We made only positive changes, but that caused us to have a different winner. Yeah. So disadvantages of the plurality with elimination is that sometimes it violates monotonicity. Any other disadvantages that you can think of? Anything you don't like about it? It's not as easy. That's true. Not as easy to understand, which is a real drawback. If you're going to try to sell people on the method that we should use to make a decision, they have to be able to understand it, right? So it's not as easy to understand, and it's takes a little time. Particularly if there are a lot of candidates, it might take a lot of time because you might have to do a lot of eliminations.
And I feel like I can see how people could get, like, I bet there's a lot of elections that if you were to just use the plurality method, where like all the people who voted for whatever the one person who won was not a majority of the votes, were probably super stoked. All those people would probably get kind of upset.
Yes. Yeah, when you use a more complicated method that contradicts a simple method, people are going to get mad when they're like, but I had the most votes, right? So the more complicated you make it, the more people can get angry at the results because they don't really understand them. Yeah.
Wouldn't that mean public perceive it as cheating?
Yes, yeah, the public could definitely perceive this as cheating or rigging an election if it's not as transparent. No, because we didn't use this method. No. But we do use this method for a lot of municipal elections, like city elections. Burlington, Vermont uses this method. I think San Francisco uses this method. Australia uses this method for its Senate seats. So it is very common. The International Olympic Committee. Sorry, House of Representatives in Australia, not its Senate. And there are some other cities too, but that people have told me and I can't remember off the top of my head. So that's it for class 2. You have a class 2 assignment in my math lab. You can get started on that. And I will see you on Monday.